Hello class, this is Case Study 5 Part 1. The title of this case study is Fight or Flight, Action and Adaptation Strategies for Climate Change. To get us started, we're going to consider this question. Let's say that you get a piece of junk mail in your mailbox that says, plant a tree, do your part to stop global warming. In fact, this is a piece of mail that I got a couple years ago. The letter goes on to tell you that the greenhouse effect can be made smaller by planting trees. So I'd like you to think to yourself right now, is this possible? And what is the process by which this could even be so? You might have heard of photosynthesis or the greenhouse effect. What is the relationship between these two processes? Well, the greenhouse effect is something that naturally occurs on our planet. The Earth naturally absorbs and reflects incoming solar radiation and emits longer wavelength radiation back into space. On average, the absorbed solar radiation is balanced by the outgoing terrestrial radiation that is emitted to space. A portion of this terrestrial radiation, though, is absorbed by gases in the atmosphere. The energy from this absorbed terrestrial radiation warms the Earth's surface and atmosphere, creating what is known as the natural greenhouse effect. Without the natural heat-trapping properties of these atmospheric gases, the average surface temperature of the Earth would be about 33 degrees Celsius lower, which is substantial. Therefore, the greenhouse effect is important for maintaining life as we know it on our planet. But we're starting to see a change because the atmospheric gases in the upper atmosphere are starting to increase in their concentration. There has been an unprecedented rise in atmospheric carbon dioxide gas in the past 100 years, due primarily to the burning of fossil fuels worldwide. Current carbon dioxide levels have not been exceeded in the past 420,000 years, which is shown from ice core data from Antarctica. Now, the National Oceanic and Atmospheric Association has been measuring carbon dioxide gas since the late 1950s at an oceanic research facility in Hawaii. And as you can see in this graph, it shows us that on average, carbon dioxide concentration has been steadily increasing over the last 50 years and continues to rise. Just some of the greenhouse gases includes carbon dioxide, methane, and nitrous oxide. Other examples include CFCs and ozone. Where do these gases come from? Well, a lot of it comes from cars, and a lot of it comes from coal-burning factories. Also, modern agriculture, both of plants and animals, releases a lot of greenhouse gases as well. Many scientists refer to what is called the greenhouse gas emissions, and we can calculate these emissions in the United States. Now, carbon dioxide is by far the greatest contributor to the greenhouse gas emissions. However, as we're going to see on the next slide, carbon dioxide is not the most potent and doesn't last the longest in the upper atmosphere. After carbon dioxide, methane is a distant second in terms of total amount of greenhouse gas released in the United States. The overwhelming majority of carbon dioxide emissions are related solely to energy use. So this table shows us the effects of these greenhouse gas emissions over time. And the main point of this slide is to show that various gases have different intensities, with carbon dioxide actually being the least intense in terms of how it affects global climate change. However, it's still important to take note that we need to decrease our overall carbon dioxide emissions. Even if we stop emitting greenhouse gases today, we still have to live with the impacts of the gases that have accumulated in the upper atmosphere for many, many years. Therefore, it is important that we limit our greenhouse gas emissions immediately in all sectors of the U.S. economy. So, can this enhanced greenhouse effect actually be made smaller by planting trees? First off, let's remember carbon footprints. We've calculated carbon footprints in our class, and the U.S. average annual carbon footprint for carbon dioxide emissions is about 44,000 pounds per year. Now, you can compare that to the global average, which is substantially less. The global average is almost 9,000 pounds per year. So, to put that in perspective, 8,800 pounds is about the weight of one adult African elephant. And so, the U.S. citizen is emitting the equivalent of 5 of these adult African elephants worth of carbon dioxide into the air. And times 300 plus million people and growing in the U.S. population, that's a lot of carbon dioxide released. So how are trees connected to these carbon footprints? Well, the first question to ask yourself is, what is inside of a tree? What makes up a tree? Where does the majority of the weight in plants actually come from? Well, plants do photosynthesis, and photosynthesis is the process by which plants can use energy from the sun and carbon dioxide from the air in order to build sugars. Now, in building these sugars, the plants release oxygen gas as a waste product. Now, at the same time, plants must also do respiration, the process by which they break down those sugars made by photosynthesis to get the energy stored in those sugars so that they can build more cells and tissues. And in order to do aerobic respiration, plants must take in oxygen and release carbon dioxide. So you can see there's this relationship between photosynthesis and respiration in which carbon dioxide and oxygen are going to be either consumed or released. So trees do take in carbon dioxide, but they don't take in as much as we might think. For example, if we planted one small oak tree that had about 6 inches in diameter, this small oak tree, while important for improving biodiversity in California, would only reduce carbon by about 49 pounds per year. Now, keep in mind that every day that we just breathe, we release 2.3 pounds of carbon dioxide. So it's going to take 17 oak trees to be planted in the ground just so that we can absorb the carbon dioxide that we're breathing out. The point that I'm getting at here is that while it is important to plant trees, it's not enough. We must mitigate our carbon releases and find ways to stop emitting so much carbon dioxide. Now, if we take a airplane and we fly from New York City to Los Angeles, that releases 1,400 pounds of carbon dioxide per passenger on the plane. And when you think about the thousands of planes in the air at any given moment in time, that's a lot of carbon dioxide that's being constantly released to our atmosphere. So remember, previously I said that the average American releases about 44,000 pounds of carbon dioxide per year due to their carbon footprint. So that includes all the products we consume, all of our transportation, everything combined. And so in order to make up for that carbon that we release, we would have to plant almost 900 trees every single year for every single American. And as you can imagine, that's a lot of trees, and we don't exactly have that much land available where we can plant that many trees. So as we've discussed all semester, the Earth is a system, and we have this relationship between life on land and life in the water. Remember, the ocean is a place that can store lots of dissolved carbon dioxide. This carbon dioxide enters the ocean by several processes, including simple diffusion from air to water and transfer from land in rivers as dissolved carbon. The ocean stores carbon dioxide, but it also stores heat. Water has the highest heat capacity of many substances. Now, a large amount of heat energy is stored in the oceans, but remember, oceans also absorb carbon dioxide, both from the atmosphere as well as from runoff from rivers. Now, part of what drives the climate system on our planet is what's called the ocean conveyor belt, in which these ocean currents circulate hot and cold water among all of the continents. And if this conveyor belt was ever to shut down, major changes in our climate would occur. And unfortunately, due to global climate change, we are starting to see these conveyors change, which can ultimately lead to some catastrophic effects. We start to see what's called a positive feedback loop. In these positive feedback loops, warm temperatures and warm air lead to increased evaporation, but instead of clouds forming, remain as water vapor. This water vapor is actually a greenhouse gas. The warmer it gets, the more water vapor we have, and the process can continue. We also see what is called a negative feedback loop, in which warmer temperatures warm the air and lead to increased evaporation. This evaporation then leads to cloud formation, which reflects more sunlight that can ultimately cool the surface of the Earth. So we have both of these feedback loops occurring at the same time, and it can cause catastrophic effects on our climate. Now, global climate change is going to have some potential environmental impacts. For example, species who can't adapt to temperature changes include things like polar bears, birds, and ocean animals. They simply have nowhere to go. As their habitat is destroyed, they could go extinct. We're starting to see a disruption of global ecosystems that leads ultimately to an extreme weather event. As sea level rises and glaciers melt, we start to see catastrophic storms, including hurricanes and tsunamis, with increasing intensity around the world. Another big problem is the spread of disease. As ocean waters warm, we start to see more diseases developing, especially in the developing nations of our planet. So, while it might be nice to think about planting trees, and it is important for biodiversity to plant trees, unfortunately, planting trees does not have a huge effect on the enhanced greenhouse effect. That said, it is important to maintain these tree populations, and it is important to modify our lifestyles so that we can reduce our carbon footprints. All right, well, that's it for this short lecture. Please email me with any questions, and thank you so much for listening.